Error control. Errors occur from malfunctions of hardware or in the transmission of data over communication lines. Let us summarize the types of error controls. 1. Error control of main memory. In the main memory, 1-bit error is automatically corrected with the Hamming code and 2-bit error detection is done. 2. Error control of auxiliary storage. In magnetic disk devices, burst errors, consecutive bit errors, caused by small flaws in the storage media can be detected. In order to allow their automatic correction, the CRC, cyclic redundancy check, code is attached. 3. Error control of magnetic tape device. In order to detect bit errors in 1 byte in the direction of the tape row, a vertical parity bit is added. Also, in order to detect burst errors that occur in a block in the track direction, CRC code is attached. 4. Error control in data communication system. A vertical parity bit is attached to each character transmitted. One of the checks, such as a horizontal parity check, CRC, cyclic redundancy check, Hamming code, etc., is attached for each transmission unit and the data is sent. The code is then checked on the receiving side. In the case of the horizontal parity check, error detection is performed and a retransmission request is sent. CRC, cyclic redundancy check, and Hamming code are classified into error correction code. Because of this, automatic correction is possible. However, the processing is complicated and therefore, it is usual to choose the method of sending a retransmission request. Let us study the characteristics of error control systems. A. Vertical parity check method. Characteristics. A parity bit is attached to each code, and a convention in which the number of bits in the state of 1 within each code, including the parity bit, becomes even parity check, or odd parity check, is established. The receiving side checks each code to see if the 1 bit is even or odd. Disadvantages. If the even bit in the code is mangled, the check cannot be done. B. Horizontal parity check method. Characteristics. A parity bit is added in the horizontal direction to each block, which is the transmission unit for data transmission. In addition, a vertical parity bit is also added to this code and checked. This single character redundancy code is called the BCC, block check character. Disadvantages. If the even bit in the block is mangled, the check cannot be done. C. Horizontal and vertical parity check method. Characteristics. This is a check system that uses both the vertical parity check method and the horizontal check method. Disadvantages. The combination of the vertical parity check method and the horizontal parity check method gives it better functionality than either method used alone. However, if there are even bits of the same bit position that are mangled in even bit sequences, the check cannot be done. D. CRC, cyclic redundancy check method. Characteristics. Calculation is done based on a fixed rule for data, generating polynomial, and the calculated result, remainder, attached to the data as CRC code. The receiving side uses the same rule to calculate and check in this method. High-level data link control procedures, HDLC procedures, use this method to detect errors. The CCITT, now the ITUT, recommendation V41's x to the power of 16 plus x to the power of 12 plus x to the power of 5 plus 1 is used as the generating polynomial in this procedure, and a 16-bit CRC code is attached. Concept of the CRC. Example. The character data A expressed by the code is 1,011 is to be transmitted. 1. Before sending it, the sending side and the receiving side decide on the generating polynomial, expressed as g, x. For this example, g, x, is x to the power of 6 plus x to the power of 2 plus 1. G, x, equals x to the power of 6 plus x to the power of 2 plus 1. Two. The data to be sent is assumed to be a higher polynomial. The transmission will occur from the low bit in order, so B1 to B7 correspond to x to the power of 6 to x to the power of 0. Three. The highest level term x to the power of 6 of g, x, is multiplied by p, x, and the result expressed as q, x. Q, x, equals p, x, asterisk x to the power of 6 equals x to the power of 6 plus x plus 1. Asterisk x to the power of 6 equals x to the power of 12 plus x to the power of 7 plus x to the power of 6. Four. Q, x, is divided by the generating polynomial g, x. Modulo 2 is used at this time. 5. The remainder r, x, becomes the CRC code. It is attached to the data and the data is sent. The highest level of the generating polynomial used in this example was x to the power of 6, so 6 bits became the remainder for the check bit. 6. The receiving side divides the data received by g, x, and if the result is 0, then the data is judged to be normal. If it is not 0, then it is judged to be abnormal. E. Hamming code. Characteristics. This is a typical automatic correction method that allows the automatic detection and correction of errors at the receiving side. In this method, the check bit that is used for error correction is included in the bit beforehand and the data is transmitted. The receiving side can use the check bit to detect the error and correct it. With the Hamming code, 1-bit error is automatically corrected and 2-bit error detection is done.